Hello professors, our team will be elaborating more about the A3 poster on improving the data tracking process. We'll first start off with the problem statement, then show the current state, find the root cause, propose solutions, and show proof that our solution works, and give possible follow-ups. So first off, one of our team members and company, which is due to NDA, we can't say it, encountered a problem in their workplace. The problem is as follows. The security department of the company assigns cybersecurity training to employees periodically. Usually, it only takes 7 days to finish the training. However, the security analyst takes 3 entire weeks to track the data of the employees on their training completion. This resulted the security department manager voicing out their frustration that it takes too long to finish tracking the employees on their training. Our goal is to reduce the data tracking process from 3 weeks to as long as the completion of the employee's training, which is 1 week, which is kind of a 66% improvement. Currently, the VSM outlines the end-to-end workflow for tracking employee training progress within the security department. It highlights the current state, including manual tasks, delay, and inefficiencies. Some of the key observation we can see here is that the process is heavily dependent on manual inputs, leading to delay and waste, and that long lead times and inefficiencies result from waiting waste, defects, and repeated manual tasks. Currently, our total time to complete the data tracking is about 21 days, with 250 minutes working on the process itself. This results in a mere 0.8% process efficiency, indicating room for improvement. So our goal is to first reduce the time to data track and ultimately send the report to the manager from 3 weeks to just a week, and hopefully allow more time for the security department to complete more critical tasks such as email and network traffic monitoring. Now, based on the problem statement, we want to find what is the root cause of this issue. In order to find out what's the root cause of the problem, we first categorize causes represented in the form of a fishbone diagram. The fishbone diagram is split into 5 major categories, with the 6 major category material not being really relevant to the problem. Upon doing the fishbone diagram, we have a lot of possible root causes which we then label it as controllable or not. Some of these controllable root causes are manual data entry and reminder system, lack of procedure, communication issues, too much employees, and a lot of regulatory demands. The survey is then conducted among the security department members, collecting various data that can help to determine our root causes. Part of the survey conducted among the security department employees requires them to choose the top 3 causes that they think affects the long data tracking process the most. Based on their ranking, 3 to 1 points are given to the causes. Then we displayed the results in the form of a Pareto chart, which we found about 76% of votes belong to these 3: manual data entry, manual reminder system, and too much employees to track.
After identifying the 3 controllable root causes, we will propose the countermeasures to address them. For our countermeasures, since our top 3 root causes is a result of manual work, we have decided to incorporate automation to minimize the errors. 2 concepts are implemented here, Jidoka and Pokayoke, and we have chosen Microsoft Automation Tools as the training platform is in Microsoft environment. Here is our entire solution at a glance. We'll be using 2 tools, Power Automate and Power Query. Our first tool is using Power Automate. It has 2 main functions: to automate downloading of raw data from company portal and to automate the email notification process leveraging on Power Query. So how does it work? For context, this sequence is prepared to show the email notification process. Firstly, it will be triggered by a designated event. Next, it initiates connections to software tools and API. Next is to configure a sequential flow. Lastly, is to check if the flow was successful and to generate a report. The concept implemented is Jidoka. Since the process goes from manual sorting and filtering with minimal machine intervention to an automatic process using Power Automate with minimal human intervention. This achieves the automation with human touch. Our second solution is using Microsoft Power Query. It has 2 functions: to refresh downloaded raw data from the company portal and to transform data at a rapid speed based on the predefined custom queries. 2 files are at play: the raw CSV file which is downloaded from the company portal and the Excel sheet that will be containing the transformed data. These 2 files are connected, allowing periodic refreshing. So how does it work? Firstly, the raw data in CSV is downloaded to begin analysis and tracking. Next, it retrieves the new data to begin the transformation. Then it goes through filtering and removal and application of custom rules. Lastly, the data will be loaded into the Excel sheet for further implementation via Power Automate. The concept that we have implemented is Pokayoke. From doing manual data entry, which is very error-prone, we have shifted to automation using Power Query, which is error-free. So since it's mistake-proof, we can deduce that it's okay. We will now demonstrate the implementation of the entire solution using the two tools covered earlier. Here's the overview again as a refresher. Firstly, automatic data import. This will run every Monday and we will download the CSV file from the company portal at 10 a.m. And then it will trigger the GET request and then it will replace the CSV file. Next, the Power Query demonstration. So we have generated a sample dataset because of company confidentiality. And we can see the column names being generated here: name, training status, completion, username, email. Columns in concern are training status, as we will be doing the filtering later on. Now the new Excel file is being created at the initial starting stage, where these two files should have the same name, the CSV file. Now the CSV data is being loaded into the Excel file. And we can see it's loaded properly. Now with that, under the training status column, we remove completed so that only employees who are in progress or not started will be reflected. And now to further show the power of this tool, we will filter out only to Outlook email. So we can see only 3 out of 1000 plus. So now once we have loaded it into our Excel sheet, this is the result we will be using later. And now just to show the refresh functionality, when we append information to the CSV, it gets immediately added on to the Excel. Now moving on to the last demo, the email notification process. We will use both tools to perform email notification. Firstly, an event will trigger a Cloud4 execution, which is when a CSV file is being modified. Next, Power Query performs to display only the rows of employees who have yet to complete the training. And lastly, we will extract values dynamically from Excel to send an email to each employee with name, email, and training status. We come back to the overview slide once again to get a full picture of the entire process. We can see how both tools work separately and together to achieve the entire objective. We will now show the results and evaluation of proposed solutions. A countermeasure trial and post-survey was done to the IT security department, which showed reduced tracking time and improved efficiency, as seen in the graphs. The desired value stream map shows that there's a much less amount of waste compared to earlier when we had skill waste, defect waste, and a lot of waiting waste, which has trickled down into only a little bit of waiting waste. And this has improved our process efficiency from 0.8% to 0.9%. Revisiting the target conditions, we have reduced the time taken to send the report from 21 to 7 and allowed more time for security department to complete more critical tasks at hand. For follow-up actions, we have completed from manual, we have shifted to semi-automated, and now we aim for fully automated with the visual management. We can enhance the current dashboard to include real-time statistics on employee information rate, analytics on the implementation of Power Query and Power Automate to show the issues in dashboard, and to have a failover plan if there is any downtime. With this, we will be able to achieve all aspects of lean thinking. Thank you.